Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will explain more trig equations, more specifically general solution. This is lesson 5 of 5. Let's start with the maths. Now I want to teach you something, and that is sometimes the questions ask for where is an identity undefined. Now a identity is undefined in two places. One, where the denominator is equal to 0, the denominator you find under the line, and when there's a tan inside your sum and where tan is undefined. So in this example, the question is asking us for which value or values of A is the identity, and then I give you the identity equal to tan A undefined. So what you do is you look at the denominator and you write it down, and then you're going to find the general solution to that denominator. You're going to equate it to 0, so you will turn it into an equation, and then you're going to find the general solution. Or the other place is where tan A is undefined. Now let's go back to the denominator. So you take whatever the denominator is, you equate it to 0, and you find the general solution. Now again, here the cos 2a, that is a double angle, and let's turn it into one of its possibilities, and I'm going to choose the one that contains the cos. So in the place of cos 2a from my formula sheet, I'm going to substitute it with 2 cos squared a minus 1. And then in the next step, I'm going to multiply in the negative, and here it will become plus 1 minus 1, and they will cancel each other out. So in the next step, I'm left with cos a minus 2 cos squared a equals 0. And spot the algebra. When the corresponding algebra there will be x minus 2x squared is equal to 0. And in algebra, you can pull out x as a common factor, and you're left with bracket 1 minus 2x is equal to 0. So back at your trigonometry, you can factorize by taking out cos a as a common factor. And then you're left with bracket 1 minus 2 cos a is equal to 0. And then if you solve that one, it will become cos a is 0, or 1 minus 2 cos a is 0. And then for cos a is 0, that is happening at a is equal to 90 degrees plus 180 times k. That means every interval of 180 degrees, you will find that your identity is undefined. And then the other part, the 1 minus 2 cos a, what will happen here is you will say minus 2 cos a equals negative 1, and then divide by negative 2, divide by negative 2, and you end with cos a is equal to a half. And then to solve that one, you find a reference angle of 60 degrees, and then therefore the answer will be a is equal to plus minus 60 degrees plus 360 times k. And then the other place where your identity is undefined is if there is a tan inside your sum. So where is tan A undefined? Tan is undefined for angle A at 90 degrees plus 180 times k, k element z. Before we continue, have you subscribed yet? And just a reminder, you can also visit my website onlinemaths.co.za. The link is in the comments below. There you will find all the chapters in the syllabus. Let's continue with the maths. Another example. For which value or values of x will 2 tan x minus sin 2x over 2 sin squared x be undefined? So remember, tan x is undefined at x is equal to 90 degrees when there's a tan inside your sum. And then the other place you find undefined is you go to the denominator, you find 2 sin squared x and you equate it to 0. And then you do a little calculation. So the first thing I'm going to do here is divide by 2, and I end with sin squared x is equal to 0. And then to get rid of the square, I take the square root. And then now I've got sin x is 0. And where is sin x 0? Sin x is 0 and undefined at x is equal to 0 or at 180 degrees, and where that tan x was, x is equal to 90 degrees. Now I found this example in an old exam paper. Let's look at it. Determine the general solution of 3 sin a sin 22 degrees equals 3 cos a times cos 22 plus 1. Let's write down the sum. Now, first of all, what I'm going to do is I'm going to take this across to the other side because I want to turn it into an equation. Everything on the one side equal to the numbers. Then I end with 3 sin a sin 22 minus 3 cos a cos 22 equal to 0. The next thing that I'm going to do is I'm going to pull out 3 as a common factor. Now, if you look at whatever is left inside the bracket there, it feels as if it's the compound angle, but you've got a problem. The problem is the compound angle is in the form cos cos sin sin. So what I did was I just swapped the two around. And now I still have a problem because of this minus. So what I'm going to do is I'm going to pull out the negative. And remember, when you pull out the negative, this one also changes into a negative. And now it's the compound angle for cos. Listen to the pattern. Cos, cos, sin, sin, A22, A22. So therefore, it's minus 3 cos A plus 22. Can you remember? In cos, the signs are different. If this is a minus, then that is a plus. And now I will just divide the minus 3 both sides, and I end with cos A plus 22 equals minus a third. The next thing I will do is I will find the reference angle, shift cos a third equals, and the reference angle is 70,5 degrees. And then I will say, where is cos negative? Cos is negative in the second quadrant. Therefore, it is whatever I find here on the left, A plus 22 equals, and then the second quadrant's rule is 180 minus reference angle plus k times 360 k element z, and then I solved A. So the answer there is A is 87,5 degrees plus k times 360 k element z. And then again, where is cos negative? Cos is also negative in the third quadrant. And the third quadrant, you will write A plus 22 is equal, and the third quadrant's rule is 180 plus reference angle plus k times 360 k element z, and when you solve A, it is 228,5 plus k times 360 k element z. I also found this example for you in an old exam paper. Given sin x is equal to cos 2x minus 1. Show that 2 sin squared x plus sin x is equal to 0. Now it feels as if these two are totally different. Are they even related? Now what you do is you start with the given part. Sin x is equal to cos 2x minus 1. And then you find a double angle for cos 2x. And I look at the rest of the sum and I see everything is in terms of sin. So I'm thinking I'm going to use the double angle for sin, 1 minus 2 sin squared x. I mean the double angle for cos, 1 minus 2 sin squared x minus 1. And the next thing I'm going to do, 1 minus 1 is nothing. And then I'm going to take the 2 sin squared x across so that it becomes positive. And I end with an equation. to sin squared x plus sin x is equal to 0. And that is exactly what they were asking. Show that it's equal to that. The next part of this question was determine the general solution of the equation sin x is equal to cos 2x minus 1. Now, in the previous sum, you have shown that that is equal to 2 sin squared x plus sin x is equal to 0. So you can start by writing that down. And now it's an equation and we're going to solve it and we're going to find the general solution. So first, let's find the corresponding algebra. In algebra, that will be 2a squared plus a is equal to 0. And we will take out a as a common factor and we're left with 2a plus 1 equals 0. So back at trigonometry, we can factorize by taking out sin x as a common factor. And we're left with, well, we took out sin x, bracket 2 sin x plus 1 is equal to 0. Now it's a proper equation and we can say sin x is equal to 0 or 2 sin x plus 1 is equal to 0. Let's solve the equation. Where is sin x 0? X is equal to k times 180 degrees k element z. Or the other one, 2 sin x plus 1 is equal to 0. I can let the 1 walk across and it becomes negative 1, divide away the 2. Now I end with sin x is equal to minus a half. And then what is the reference angle? Is 30 degrees. And then I will say, where is sin negative? Sin is negative in the third quadrant, which is the 180 plus reference angle quadrant, and I end with x is equal to 210 plus k times 360 k element z. And again, where is sin also negative? Sin is negative in the fourth quadrant, which is the 360 minus 30 quadrant. And then when you solve that, you find x is equal to 330 plus k times 360 k element z. Now you know how to solve trig equations, more specifically the general solution. Click on the video in the left-hand corner to take you straight to the next playlist. There you will find trigonometry, compound and double angles. This is Miss Pythagoras signing off till next time.